Hello, friends, a podcast to review section 6.1 in the AP Stats book. We have begun our section on probability, and 6.1 is specifically about simulation. The first real issue at hand is what a probability model is. Very simply, a probability model lists all the possible outcomes for an event, and we call that list the sample space, and gives the probability that each one of those outcomes occurs. So that's what a probability model is. The sample space, the list of all possible outcomes, accompanied by the probability of each one of those outcomes. The reason that we simulate is to see what would happen in a random event just by chance. So by assigning numbers and using the calculator or a random digits table, we can look at how often, if I flip a coin, how often am I going to come up with only 3 heads out of 10? Or if I'm a 70% foul shooter, how often am I going to make 9 out of 10 baskets? And I can find how likely these outcomes are just by random chance. Later, when we get to inference, we're going to be able to compare what would happen just by random chance to actual data that we record in a problem. And then we're going to be able to say whether a hypothesis, a statement, is true or not, most likely not true. But that's later. For right now, we just want to be able to follow these following steps. All right, these are in your book. So we're going to state the problem, specifically state what the event that you're describing is, and then state assumptions. And you're going to have to say something about equally likely, and you're going to have to say something about independence. Just quickly, independence in the real world means that the outcome of one event does not affect in any way the outcome of the next event. So if I flip a coin once, the outcome of that flip does not affect the outcome of the second flip. All right, so you have to at least mention something about equally likely and about independence. All right, then this process that we started practicing back when we were doing data analysis earlier in the year, but assigning digits. So if it was a coin flip, I could assign the number 1 to a heads and the number 0 to a tails and pick numbers between 0 and 1. If it was a 70% foul shooter, I could assign the numbers 1 through 7 to mean that the shot was made, and the numbers 8, 9, and 0 to mean that there was a miss. And then I can use the calculator or the random digits table to just pick random numbers and see what would happen. And by simulating this, we get an idea of what would happen just by random chance. So you should be able to assign those numbers and follow these steps right now. So this is also in your book, but this is the big ideas from section 6.1. Let's take a look at some of the problems that you would have to face. In your book, you got problem 613. You can pause this and read the problem. They ask you to describe a correspondence, and we're talking about a deck of cards. So we got 52 cards, so we could let the numbers 1 through 13 represent a heart, and the numbers 14 through 52 represent a not heart, and then we could just pick random numbers. And you should know that if you go to the random digits table, you take them 2 at a time, and if a number that isn't between 1 and 52 comes up, you just ignore that number and you go to the next 2-digit number. So everyone should be familiar with that. All right, now so I've drawn out some notation that you just might as well get used to. What I've shown here for the second part is that the probability of getting a heart on the first card is 13 out of 52. So if this happens, you win. And this second bit of notation right here means what is the probability of getting a heart, in other words, on the second card, if the first card was not a heart. And you should recognize that little C there. That means complement. So the probability that you get a heart on the second means that after you've picked the first, there's 51 cards left. All right. And so I would have to multiply 39 over 52 times 13 over 51. That's the probability of this event. Now, the probability of you losing would be I don't get a heart on the first and I don't get a heart on the second. So if I multiply these two out, this comes out to about 0.56 if you round. So there's a 56% chance that you're going to lose this game. So it is not a fair game. At least I wouldn't call it a fair game. So the notation and the multiplication principle are all things we're going to hit later, but might as well get used to it now.